Russia's MiG Aircraft Company, part of the United Aircraft Building Corporation, has patented a system of a fighter jet's automatic approach for landing in adverse weather conditions for MiG-29M, M2, and MiG-35 aircraft. The company's press office announced. The new device integrates several innovation units, drive mechanisms and systems, including the navigation and measuring equipment. It will enhance the safety of piloting in adverse weather conditions, enable a pilot to reach the glide path in the automatic mode, cut the time of making an approach for landing and ensure a safe descent until visibility appears. As the MiG Aircraft Company said, the technology will find its application in MiG-29M, M2 and MiG-35 planes. The system's advantages have been confirmed by flight tests with pilots' positive remarks, the press office said. "We are planning to introduce the new automatic landing system developed by our engineers into modern and future MiG aviation complexes. The work is already underway. Safety and the maximum efficiency of the use of aircraft are among the main priorities of our engineers," the press office quoted MiG Aircraft Company CEO Ilya Tarasenko as saying. Russia unveiled the MiG-35 at the 2007 Aero India Airshow in Bangalore, amid Moscow's keenness to sell these planes to India. The MiG-35 was a contender with the Eurofighter Typhoon, Boeing F/A-180F Super Hornet, Dassault Rafale, Saab JAS-39 Gripen, and General Dynamics F-16 Fighting Falcon in the Indian MRCAA competition for 126 multi-role combat aircraft to be procured by the Indian Air Force. During the competition, however, India's Ministry of Defence was frustrated with the problems of the aircraft's avionics. The radar could not achieve the maximum targeting distance during the tests, and the RD-33MK engines were not shown to reach sufficient thrust. As a result, the MiG-35 was ousted from the contest in April 2011. In May 2013, it was reported that Russia intends to order 37 aircraft, 15 in August 2013. The Russian Defense Ministry reported that the purchase, worth $37 billion, $1.1 billion, will be delayed until 2016 due to the spending cuts in the state arms program for 2014 to 2016. In August 2015, Colonel General Viktor Bondarev, commander of Russia's Air and Space Forces, stated that MiG-35 development was to be completed in 2017, entry into services to follow in 2018. The state tests of the MiG-35 was to begin in 2017 with completion in mid-2018 after the serial production of the aircraft would started. According to Viktor Bondarev, Russian Aerospace Forces plans to replace its whole fleet of light fighters with the MiG-35s, and thus there is a need for at least 170 of such aircraft. During 2016, first two pre-production aircraft were in active phase of construction at the Production Center No. 1 in Luhavice. Both aircraft were delivered at the end of the year. In July 2017, during the MAKS 2017 International Aviation and Space Salon, the Russian Defense Ministry agreed it will buy 24 MiG-35s as a part of the new state armament program for 2018 to 2027. Although 37 aircraft were previously planned, 6 out of the 24 MiG-35s will replace the aging MiG-29s of the Russian aerobatic team SWIFTs. On the 22nd of August 2018, during the International Military Technical Forum, Army 2018, the first contract for 6 MiG-35s was signed. The Russian Aerospace Forces plans to sign a second contract for delivery of 14 MiG-35s in 2020. On the 17th of June 2019, Russian Aerospace Forces has received first 2 serial MiG-35S fighters, marking the introduction of the variant into service. McCoy and MiG-35 is the continued development of MiG-29M, M2 and MiG-29K Cub technologies. This aircraft is challenging as a Generation 4++ Sonner by Mikoyan. The aircraft's first prototype was a modification of the plane that had been carried out as a demonstrator for the MiG-29 M2. 10 prototypes have been built and are being screened in the field that was launched. The MiG-35 is now launched as a mid-class fighter because its takeoff weight has increased to 30% from the previous prototype, which exceeded the classification criteria for light class aircraft. The MiG company officially presented the aircraft at an international event at the Aero India Air Show in 2007. The MiG-35 first approved the compilation of the Russian Ministry of Defense, Sergei Ivanov, to open an engine manufacturing plant, Mopo MiG. The one-seat version is named the MiG-35 and the two-seat version is named the MiG-35D. This fighter gets a considerable increase in avionics and weapon systems, the AESA radar system, GCI, and allows this aircraft to enhance mobile multi-role missions. There are references in the late 1980s to a very different design also identified as MiG-35. This design was a single-engined combat aircraft for air-to-air and secondary air-to-ground roles. According to unidentified Indian sources, the aircraft was evaluated by Indian pilots in the Soviet Union and was probably suggested as an alternative to the Indian LCA being developed at that time. The MiG-35 is powered by two FADEC RD-33MK Morskaya OSA turbofans. The RD-33MK, a highly improved variant and the latest version of the Klimov Road 33 turbofan, and was intended to power the MiG-29K and MiG-29 Cub. It has 7% more power compared to the baseline model due to the use of modern materials in the cooled blades, providing a higher thrust of 9,000 kilograms force. In response to earlier criticism, the new engines are smokeless and include systems that reduce infrared and optical visibility. The engines may be fitted with thrust vectoring nozzles, which would result in an increase in combat efficiency by 12% to 15%, according to manufacturer claims. The RD-33OVT engine variant comes with thrust vectoring nozzles and can direct thrust in two axes. As of 2012, the only in-service, in-production fighter jet using this technology is the Sukhoi Su-35. Other current thrust vectoring aircraft, such as the Sukhoi Su-30 and the Lockheed Martin F-22 Raptor, have nozzles with thrust vectoring in one axis. Thrust vectoring capabilities enable an aircraft to use highways or grass strips for landings and takeoffs instead relying on traditionally prepared asphalt runways. In January 2017, during a conference call with Russian President Vladimir Putin, Yuri Slyasar, president of the UAC, reported that the MiG-35 could possibly use a kind of laser weaponry in the future. Military trials of the laser are to proceed immediately after flight testing of the aircraft. However, there was doubt if Slyasar made a mistake by saying laser weaponry instead of laser-guided weapon. The MiG-35 is also planned to be capable of launching the Kh-36 Grom-1 cruise missile, giving it a long-range strike capability that the MiG-29 does not possess. The MiG-35 has a glass cockpit equipped with night vision goggles, an additional display for the optical locator system, and a 3 equal-size color LCD multi-function display. The second-seat version of the MiG-35, the MiG-35D, has 4 LCD displays in its rear cockpit. The MiG-35D uses a tandem cockpit while single-seat versions of the MiG-35 uses the rear cockpit to store extra fuel, while retaining a two-seat canopy.